All right, this is December 10th pre-calc lesson. We are going to start on worksheet 10A by talking about identities. But before I do that, the review packet I handed out to you today is what the quiz will look like on Friday. The problems that are not on the quiz that you may cross off are number 23, 28 and 29. 23, 28, and 29. One more time, 23, 28, and 29 may be crossed off. Now, this is not worth points. The answers are on the back. One answer is wrong. I will tell you right now that 19B is wrong, but that's probably a problem we should go over tomorrow in class anyway. So I'm not going to spend a lot of time on that. Please look this over tonight so that you know which questions you need to ask me in class tomorrow. You don't need to do it all tonight. It would be good practice tomorrow night to do, but does it make sense that you need to go, okay, I'm going to look at number 7. I have no clue how to do that, so I better ask tomorrow.
Yeah,
all right?
Makes sense.
Makes sense. Now, worksheet 10A talks about what is an identity. An identity just means it's basically a trade for something. So this is an identity. 2 times the quantity x plus 1 is equal to 2x plus 2. It's an identity. They're both equal. You could trade one for the other, okay? These are the identities you need to know, but you don't really need to know them. You need to know how to use these, okay? But this is on worksheet 11B, and worksheet 11B is a copy of what you will be given for the final and for the quiz on Friday. One more time, you will be given worksheet 11B on colored paper for the quiz and for the final, okay? So these are on that page, yes? Everybody looking at 11B, there's a little chart in the middle that says this. Okay? The basic identities. These should be familiar. Cosecant is 1 over sine, therefore sine is 1 over cosecant. Are we good?
Yeah.
On this little chart, the only ones that I think might not have talked about too much yet are really important trades, or you can trade a tangent for a sine over cosine, which means a cotangent is the flip of that, cosine over sine. All right, those are two that we haven't talked much about. Then there are 3 very important identities called the Pythagorean identities. And they're really built off of the unit circle. If we go here, cosine is x value and sine is y value. And if we make this a unit circle with a radius of 1, the equation of that circle is cosine squared plus sine squared equals 1. Remember when I told you the only thing in the whole wide world that I have memorized is that pi radians is equal to 180 degrees?
Yeah.
Okay, I lied to you.
Oh, I knew it.
I also have memorized cosine squared plus sine squared equals 1. And I will be honest and tell you, that is the only one that I have memorized. The other 2 that we're going to talk about right now, I have to write them out every time because I don't have them memorized. The other 2 identities that are important, Pythagorean identities. Why is it called Pythagorean identity?
Because it's
Square.
Yeah, it's built off a right triangle. It's just the Pythagorean cosine squared plus sine squared equals 1 squared, okay? They do have to be squared. Talk more about that in a second. But if I divide all these by cosine squared, cosine squared over cosine squared is 1. Sine over cosine, anybody remember what sine over cosine is? We just talked about that. It is tangent.
Isn't tangent squared though?
Yes, because this is a squared, the tangent would be squared.
So what if it was like sine over cosine squared?
Then it's not anything, okay? They have to both be squared to be able to trade it. Or it's a tangent times a 1 over cosine, which would be a secant, tangent times secant, which is not a very good trade, probably. All right, 1 over cosine squared is secant squared. So this is the other one, another one. By the way, before I turn this page, I do want to talk about what cosine squared means. Cosine of t times cosine of t. When you type it in your calculator, you have to do this. Okay? Which there's no reason for you to type these in the calculator yet, but next semester when we type them in, it's going to be typed like this. But because that's a whole bunch of parentheses and a whole bunch of pain writing, they shortened it down to just cosine squared of t. But it's not the cosine that's squared or the t that's squared, it's the whole function. Cosine of t times cosine of t is shortened to be written this way. All right, there's one more. The other one is if you have cosine squared plus sine squared, what did we divide by last time?
Cosine squared.
So we're going to divide by sine squared this time.
Ooh, cosine reverse.
Okay, cosine squared over sine squared, anybody?
I don't really.
Cosine.
Well, if tangent was sine over cosine, then cosine over sine must be the flip of tangent, which is cotangent, yep. That's
We
a,
don't have to memorize any of these, do we? Except for just like one, so cosine squared plus sine squared.
they're all on the sheet that you get. Sine squared over sine squared is 1, and 1 over sine squared is? Okay. So those are the three and how you get them in their relationship to each other. But at the bottom of 10b or in the middle of 10b somewhere is this little table. And that information is also on 11b. These are the three Pythagorean identities. And those are the way I'm going to give them to you. You're in pre-calc. I'm not going to give you every variation of those on the sheet. But let's talk about the variations because you can trade them for other forms of that. In other words, a cosine squared, theta or x or whatever, is also equal to a 1 minus sine squared. Is everybody okay? All I did was subtract the cosine over there. They will also do tricky things like this. Well, this is a 1 minus something squared, so it's really a 1 minus sine times a 1 plus sine. It could factor, or the other way around. Okay? They will also do crazy things like cosine squared minus 1 is equal to what? If I subtract this 1 over here, what do I get? Very good, crowd. A negative sine squared.
A little fast.
Word sine squared equals 1 minus cosine squared.
Yep. Okay. Do you want me to write some more of these out, or do you get the idea that you can rearrange any of these using your basic algebra manipulation, adding and subtracting things over to the other side? What you can't do, okay? I can't stress this enough. You cannot do this.
Sine, cosine.
And get, yeah, it's a funny end, sorry. You can't square root that and get this, right?
Right, because it
What? What is the square root of 1, Victor? It's 1. But the issue is
add it, right?
you can't ever do this. When it said this, did that mean we could go, oh yeah, that means a plus b equals c? It doesn't work, okay? It doesn't work. If you want me to talk about why it doesn't work, this is a Pythagorean triple. But does 3 plus 4 equal 5?
Yes.
In Victorland. Okay, so you can't, they always have to have the squareds or you can't trade them for Pythagorean identities. Did I make that clear enough? It's got to have the squareds or you can't trade them in. If it looked like this, you could FOIL it together and then trade it, okay? Let's look at, this is still on 10b, okay? This is still on 10b. These are very basic. Somebody pick one besides 16. I'm going to do 16 for sure. Okay. 15.
You take out a cosine?
Yeah, 15 we're going to take out a cosine. That's a little bit crazy, but we're going to factor out a cosine. Guys, I'm recording. Could you not be talking? When I take out a cosine, I will have left a 1 minus cosine squared. And a 1 minus cosine squared, if we flip back a couple slides here, a 1 minus cosine squared, I think it's just a sine squared, right? 1 minus cosine squared would be a sine squared right here. So 1 minus cosine squared is a sine squared. And there is nothing else we can do with that question. And I agree if you were thinking, am I done? Because usually the answer is very basic when you're done. The answer is 1 or cosine or sine squared or something easy. This is a mess, but there's nothing else we can do with that. Yep, we're going to do 16. 16 is nicer in the end, but it definitely starts out uglier. Can we cancel anything?
Can't we do like, what isn't it? Can we cancel cosine?
No. We can't cancel anything because there's glue to begin with, right? Everything on the top is glued together with plus signs, but I can add in any order I want, right? So what do you think, Emily?
Well, you have to add sine and cosine from square to 1.
So Emily's idea is, what if we rearrange this so we can add these two together, and then we'll have what? 1 plus tangent over secant. Now, 1 plus tangent, is that a trade too? 1 plus tangent is a secant squared. This is looking good. So we have a secant squared over a secant. Then what happens?
Divide. But I'm kind of confused. Wouldn't it be like sine squared over secant plus cosine squared over secant, so you can't really add them? Alright. Maybe we can. I'm just kind of
Okay, let me go back. If you have 2 plus 5 over 11, it is the same as 2 11ths plus 5 11ths, but it's also the same as 7 11ths. You can go ahead and add them. Is that okay? You all right? You could break them apart and put each one, but I just think this is a faster, simpler way to do this. Okay. We're not quite done.
Are we almost just going to simplify that, or are we going to have to do this stuff too?
This semester, we're only simplifying. Next semester, there will be all kinds of prove ones. I like the prove ones better because they tell you what you're trying to get to. You just got to show all the steps. Yeah. These are just simplifying this semester, and the ones on the quiz and the ones on the test are very basic, like some of these up here. Okay? Yes.
Is the goal to get to like sine and cosine?
Hopefully, or 1. Sometimes everything will cancel and you get a 1 or a 2 or. Yes, but like this one didn't get to that, so sometimes you're like, and it's okay, honestly, on a test or quiz, if you brought your paper up to me and said, am I done? I would tell you yes or no, okay? I'm not gonna tell you how to do it, but if you're not sure it's completely simplified, I would tell you yes or no. All right, we didn't finish this one though, guys. What's a secant squared over a secant?
Secant.
Yep, one of these will cancel one of those, and we have left secant of u. All right, on worksheet 11A. I think this worksheet does have a lot of extra room for you to work, right? 11A? You might still need scratch paper.
Scratch papers for scrubs.
Hand itches. Even my hand itches.
Okay, the one I am going to pick to do with you right now is 24.
You cross out 23 also?
Yes, you cross out 23. It's on your assignment sheet that you don't have to do 23. Okay, number 24. I'm gonna do a little basic trade right away. I'm gonna rewrite tangent as what, maybe?
Secant. Wait, what? No.
Tangent is a sine over cosine.
If it, wait a minute, if it was 1 plus tangent squared, then I think, yes, it would equal a secant squared. But it's not a squared, so we can't use any of those Pythagorean identities. Good question, good thinking. Now, I will tell you, 4th period, I let them decide how we should start this problem. And we took about 4 little rabbit trails before we finally figured out the best way to do it. We kept starting over. So these are hard, but on the test or quiz, they're not this hard anyway. I am going to give you some hints, and we're not going to follow a whole bunch of rabbit trails, okay? What is tangent?
Sine over cosine.
That's what I did first. This is being divided by 1 plus cotangent, which is 1 plus,
1 over tangent.
yes, or cosine over sine, since we did everything else in terms of sine and cosine. Does that seem okay?
Yeah.
Now, when you divide fractions, you flip the second one over. But do we have 2 fractions yet? We have kind of mixed numbery things going on, right? We got a 1 plus. So we need to get this, each parenthesis to be a single fraction. So I need the dreaded common denominator. What will 1 become if we need its denominator to be cosine?
Cosine over cosine.
Yes, cosine x over cosine x. And in this parenthesis, this 1 needs to become what? So it will have a common denominator. Sine x over sine x. Okay, you're in pre-calc. Pronounce them correctly. All right. Quick review again. Lizzie and I just talked about this. 2 plus 2 11ths plus 5 11ths is, you add the top, keep the bottom. You just keep the bottom once, right?
Yeah.
So this becomes cosine plus sine all over what?
Cosine.
Can we just cancel those cosines and be done with it?
No.
No.
No, there's glue on the top with that adding.
I hate glue.
Okay.
I like tape more.
Divided by, yeah. What's here?
Cosine
Sine plus cosine over sine.
sine.
I beat you.
I don't care.
Okay, now are we finally at that magical place where we can
Yes.
flip the second fraction over
Great.
and multiply? So we will get cosine x plus sine x is still over a cosine of x times, we got to flip this one over, sine x over sine x plus cosine x. All right, is a sine plus a cosine the same as a cosine plus a sine?
Yeah. So you cross divide.
Okay,
sine
this
over
quantity
cosine.
is exactly the same as this. So if all of this is on top and this is on the bottom, we are dividing, we can divide that quantity out. We are left, therefore, with a sine x over cosine x. Anybody know what that is?
Question.
These did say simplify to either a constant or a basic trig function, and this tangent is a basic trig function. Yes. I do not think any way we tried earlier was not getting us there any faster if it was getting us there at all. Yes.
Are cosecant, cotangent, and secant basic trig functions, or do you put like 1 over cosine?
I would accept either one, okay? On the quiz, I know it does specify it. There's a question on the quiz where it says, take this mess and simplify it in terms of cosine. So it's telling you your answer needs to be cosine. So you're either going to end up with a cosine squared or a 1 over cosine, or, so if it was 1 over cosine, leave it that way because it said to leave your answer in terms of cosine. Does that make sense? Okay. Otherwise, on a test or quiz, if it didn't specify, either 1 over cosine or secant, which are equivalent, would be fine with me. Does that help answer that question? All right. I don't think I did another one on this page. I left you guys the rest. On this page, I would like to talk about number 31 and 32. I'm going to do 31 on this slide, and then I'm going to do 32 on the next slide. honestly, I did not find a good way to do this one. Do we want to let you guys try it? I mean, I know I did it, but do you guys want to offer some suggestions?
Change.
Skip it?
Yeah.
Turn everything to sines and cosines?
Yeah.
Is that,
We should, yeah.
that's how I usually start if I'm no ideas? So tangent is sine over cosine. And that first one is being divided by a cosecant squared, which is a
1 over c sine squared.
1 over sine
So
squared.
then sine would go into the numerator, so it's sine cubed over cosine?
Yes, it's going to become that. Yep, absolutely. I'm just gonna go ahead and write the second parenthesis though before we do that. Tangent here is still a sine x over cosine x. And secant squared is 1 over cosine squared.
So would it just be
And you don't need to necessarily write this, but I'm gonna write what Lizzie's getting at, is that this is being now multiplied by the reciprocal of this, right? And the second parenthesis, when we flip and divide,
It's just sine times cosine, right? And then
oh, that was a 1. Where did that come from, Hoffbauer? All right. So Lizzie said this becomes a sine cubed. Everybody okay?
Yeah.
Over a cosine. Plus, this becomes a, you know what? This is where we got to. I don't think you want to simplify this. Because doesn't it, if we leave it over a cosine right now, we have a common denominator. I think it's better not to cancel right there and to keep it for a minute. Because I want to get rid of these double fraction things as fast as I can. Because now they have a common denominator, right? So I can make it 1 fraction. That just sounds better to me. So I have a sine cubed plus a sine times a cosine squared.
Oh.
Oh my god.
Sorry, Sierra.
Don't cry,
Stop. Go away. That's not even the right page, is it? What happened? Is that where we are?
No, that's not.
Is that where we are? Okay. Phew. Got totally lost there. All right. Ideas? Yes. Shayla said take a sign out on the top.
Beautiful.
Because if we take a sign out of this piece right here, what will be left?
Sine squared.
If we take a sign out of this piece right here, what will be left?
Oh, 1.
A cosine squared. Woohoo!
Hey, look at the best. We love you.
All right, so we're going to take out a sign. That will leave a sine squared plus, we took it out of this and out of this. So that will leave a cosine squared. Then what?
Then that equals 1, right?
This is 1.
Yeah.
So 1 times sine is just sine, and sine over cosine is?
I feel like it's almost tangent.
Yes, all of the answers are tangent. Just go with that.
Okay, question. I don't understand the last blue step to the red step.
This one to this one.
Yes.
Okay. There was a sine cubed plus a sine times this. So it's like we had an x cubed plus an x times y squared. We took an x out.
Okay. So wouldn't it be? Oh, dang it. Okay.
You all right?
Yeah, we.
It does help sometimes to think about it differently.
Okay. Gotcha.
Great question. Anybody else have a step I can explain again? All right, one more, and then we're going to do some angular and linear velocity. We're going to do 32. I thought I had put in a page with a 30. I'll do it quick now. It's going to be tangent. I'm gonna cry if it comes out tangent, because then you are gonna think they're all tangent.
Mm-hmm. Don't do that.
I don't think I did that right. What did that just do?
Oh, you made it bigger. That's good. That's good.
Well, it's kind of a mess, but I think we can read it,
Well, yeah,
can't we?
Secant squared x cosine.
Okay.
No, cosecant
So,
squared.
I don't think there's anything nice we can do with this. So, let's try something. What is a secant squared?
1 over cosine squared.
Times a cosecant, which is a
1 over sine.
not squared, okay? Be careful. This one is squared, this one is not squared.
Could've tricked you.
Yeah.
Dirty players.
All over
1 over cosine squared.
1 over cosine squared plus.
1 over sine squared.
Now, before we can do any flipping, it has to be one fraction, right?
Uh-huh.
So this is not one fraction down here.
So then we're gonna hit some
The common denominator down there is going to become what?
Cosine
Cosine squared.
Yeah, blah, blah, blah. Okay, we're going to have to multiply this fraction by a sine squared over sine squared. And this fraction over here by a cosine squared over cosine squared. So that we have a sine squared times 1 plus a cosine squared times 1. That sounds like a good plan. And the common denominator was sine squared times cosine squared, right? I'm feeling all happy that I wrote that all nice and readable, and then I just realized that,
Is it wrong?
no, all of that was on top of all of this. So I'm going to write it over here.
Oh, dang it.
So these,
I'm going to write it like this. All of that is now over all of this. That's really a good way to write it now that I think about it, because we need to do some flipping. But before we flip, is there something we could trade? I have 12 rolls of quarters. I think I should go to the bank and trade them for 12 $1 bills.
Wait a second.
Miss-
Rolls of quarters are more than.
Oh, yeah, rolls of quarters are they're like $10 a piece. Yeah, you're right.
$120.
Okay, so I'm not making a good trade. That's what Miss Falzone used, when she teach this, she would say it's like the bank of trig trades, okay? You could go to that little bank and trade things out. Well, what are we going to trade out here for a sine squared plus a cosine squared?
Tangent squared. No.
Or a 1.
Try this.
I just like.
All right, divide is flip it over. Can we make this one fraction up here, guys? When you multiply, you don't need a common denominator, right? So this is 1 over a cosine squared times a sine. That's lovely. Divided by becomes times, and we flip this over.
Your face is looking.
We have a sine squared, cosine squared. Does everything cancel?
Nope.
no.
Sine.
No, because remember the trick was earlier on, this was only a sine, not a sine squared. So the cosine squared, why can I cancel all of a sudden?
Because you're multiplying, not.
There's no addition left anywhere. Okay. So this sine squared divided by a sine is just a sine of x.
We should just like guess each time, and we have a 16.6% chance of getting it right.
There could be negative sine, negative cosine, there can be a 1, a 2,
So like
a negative 1.
5% is good enough.
Okay. You could get, on the quiz, one of them is multiple choice, so you can guess. It's a 1 and 4, okay?
25 is good. I could have done that for my Spanish
All right.
last year. And I would have got my A.
I am going to switch over to this. Can we go to worksheet 4A? Worksheet 4A. Do I need to separate some juniors who can't sit by each other without talking? All right.
What's in your elbow?
On worksheet 11B, besides the trig trade identities and all that good stuff, are also some formulas. This formula is there, and it means linear velocity is equal to angular velocity times radius, where the angular velocity must be in radians per time for this to work, okay? This particular question wants an answer in revolutions per minute. RPMs are related to radians per minute. They're not the same, but they're related. And radians per minute is an angular velocity. So we have to find an angular velocity. How could we rearrange this formula to get the angular velocity by itself?
So sigma on the left divided by r.
I'm with you because I'm not confident in these names. The V-looking thing divided by the R is going to give us the W-looking thing. Okay. This is a linear velocity. What is the linear velocity we're given in this question? 24 feet per second. We want to divide that by a radius, but what is the radius?
10.
The radius is 10 inches. Does it feel like we might have a problem?
Convert it to feet.
Yeah, this is feet.
10 over 12.
You could change that to feet. You're right. You could change that to feet, but most of us would probably say 1 foot is 12 inches. Is that right?
I think so. Yeah.
Pretty close.
Yeah, I did it wrong. It's right. Thank you, Madison. 1 foot is 12 inches, but we need it written that way, inches, so that these cancel. Okay, I think that's 288
Wait. Yeah. Yeah.
inches per second. And now we can divide by our radius. Our radius is 10 inches. 288 divided by 10 is 28.8. And we have inches canceling out. We have nothing per second. What is nothing per second? The magical units in trig are radians. Okay? The magical units. Pi is not a unit. Okay? The magical units are radians. So we have 28 radians per second. Is that an angular velocity?
No, because it's called minute.
Okay? We want revolutions per minute. We're close. What do we need to do?
Like geometry.
60 seconds per minute. So now we have radians per minute. Unfortunately, it doesn't want radians per minute. It wants,
Revolution.
where do we need to write radians? Revolutions on the top. What's the conversion?
Uno reales, dos pies.
Okay.
Yes.
We had a lot of trouble with this question last period because people didn't listen when I said if you're going to divide by 2 pi, how do you need to type that into your calculator?
Dos pies. No. 2?
If I type 0.8 times 60 divided by 2 pi, I didn't write divide, did I? What is your calculator going to do?
You want to cut, you want to come on.
Yes, your calculator is going to divide by the 2, and then it's going to take that answer and multiply by pi. If you want both the 2 and the pi to be in the denominator,
Or,
you need some parentheses.
or you could do 28.8 times 30 over pi.
Yep, you could divide the 2 into the 60 first, or the 2 into the 28.8. Okay, but if you don't put the parentheses, you don't get the right answer. Somebody give me an answer.
275.
275 revolutions were left after we canceled these per minute. And you can write revolutions per minute, but the abbreviation is also RPM. So, if she's literally, if that's how fast her wheel is turning, if she had a standard bicycle with no gears, she'd have to be making her legs and feet go around 275 times a minute.
We can do that.
How many
Seems
times
kind of fast for me.
It's got nothing.
All right,
It's 4 times a second.
I am skipping to problem 55.
2, 3, 6, 1.
Okay, I want to get 55 done and in our notes. It is talking about a belt that goes around 2 metal wheels, so I made a slide here with a stolen picture from the internet. The numbers aren't right, but this is the concept. Do you understand what's going on, guys? We have 2 wheels with a belt around them, okay? On our particular air conditioner, automobile air conditioner, the smaller one has a radius of 4 centimeters. Well, the labels were right. We don't care about how far apart they are. But the bigger one has a 7 centimeter radius, okay? What is the other thing that we know?
120 RPM.
Okay, this one is turning 120 RPMs. Is this one turning 120 RPMs?
More, probably.
It has to turn more times to keep up, yes?
Yeah.
No? We don't get it?
I get it.
Can you just? Yeah, yeah. That's what I'm thinking. 7 to
Okay.
4 times 120.
But to answer all the questions along the way, we're going to have to do some converting. The first question says, what is the angular speed of the larger wheel? Well, they told us it's 120 RPMs. Okay, which is revolutions per minute, if I could write. But that's not what they want. What do they want?
They want in radians per second.
Okay.
So
Revolutions per minute needs to be changed to, and they were specific, they want radians per second. Okay, what are the conversions I need?
60
well, you got
seconds.
one revolution is 2 pi.
1 revolution would go down here so that it cancels. 2 pi radians would go up here.
1 minute is 60 seconds.
Very good. 1 minute would need to go up here so that the minutes cancel is 60 seconds.
So isn't it 4 pi?
Minutes, minutes, revolutions, revolutions.
Yeah, it is.
Yes, it comes out 4 pi, because 120 times 2 is 240, divided by 60 is 4 pi radians per second. And because we're going to use that number throughout the problem, I'm just going to leave it. If you want to multiply it out, it's fine.
Yeah.
So what did we just find? The angular speed?
Yes,
That's
we
is
found
that
an
W?
angular velocity in radians per second.
W.
What is the linear speed of the belt in centimeters per second? The linear speed is equal to the angular speed times the radius. Well, the belt is going whatever speed this big wheel makes it go, and this big wheel has a radius of
7 centimeters.
so 4 pi radians per second times 7 centimeters would be what?
28 pi.
28 pi centimeters per second. What happened to radians?
Radians aren't a real thing.
Yeah. They're not a real thing, yes. They're imaginary and they poofed, okay? They're gone. The belt is going the same speed at all times around both. Does that make sense? But to keep up, this little one has to turn more times. If we have an angular, what is the angular speed of the smaller wheel? Linear divided by radius equals angular, yes?
Yeah.
So the linear speed of the belt is 28 pi centimeters per second. If we divide by the radius of the small one, which is how much? 4 centimeters. We get 7 pi, because we're dividing, and centimeters divides out, so we have nothing per centimeter, which becomes, whoops, that's not centimeters, radians.
Radians are just clutch. They just come up with these radians.
Oh, 7 pi is 26. Well,
Okay. When we do these questions next semester, which is the first time you will see this on a test or quiz, and you will see this on a test or quiz next semester, I will likely give you a little chart like this. The radius of the small one was,
4 centimeters.
and the large one was,
7 centimeters.
and when you multiply that by the angular velocity, you get the linear velocity. This one was turning,
120 RPM.
was this one? Okay. So times 2 pi. And we changed it to seconds by dividing by 60, right? But we couldn't even, yeah, because we did times 1/60th, we changed to seconds. So it turned out to be 4 pi radians per second. Then you would multiply and you would get 28 pi, which we did, centimeters per second. The idea with this chart is that the belt is going around both of these at the same speed, so this is also 28 pi centimeters per second. The belt is driving both of those. So then if we go backwards, we want to know what went in this box. Well, we multiplied, so we do what?
Divide by 4.
So sometimes students like the little chart because it helps them see how things are related, okay?
So
You'll be given that as an optional way to solve this when we do these second semester. There is not one on the quiz or test this semester. Yes?
so in any case like this, the linear velocities are going to be the same, no matter what?
If the two objects are being driven by the same belt or something, yes. We're gonna do bicycle problems where they're driven by a chain, but yeah, where the gears are driven by a chain. Okay. One more thing before we finish up. Can you switch to the worksheet that I gave out yesterday, the angular and linear velocity worksheet?
I think we died.
Not good.
I'm actually-
Sugar, have sugar. Diabetic coma.
Catch it.
Beautiful. Just almost hit you on the face. Got it.
All right. We left off on the back of this worksheet. I gave it out yesterday. I think I crossed off 14 and 15. Does that sound familiar?
Yeah.
Okay. We talked maybe about how to do 16 through 18. Yes?
Yeah.
We just had 12 pi radians per minute.
For 1 minute. I don't know.
You just multiply each one.
Yeah, multiply each one by 2 pi. Okay. That brings us to this section. Guess what? We're looking at this little letter and this little letter and this little letter. Do we have a formula that relates those on 11b?
Uh-huh.
It says this is equal to this times this. But what are we trying to find on this section?
The
W.
angular velocity.
The angular velocity here. So what do we need to do?
Divide by radius.
This divided by the radius. So if we say 5 centimeters per second is being divided by 10 centimeters, well, 5 divided by 10 is
1/2.
1/2 or 0.5. And what label is left?
Seconds.
Second.
Well, something per second, right?
Radians per second.
Okay, so you should be able to do 20 now. What other one can I help with?
23.
23 says a mixing blade on a food processor extends out 3 inches from the center if the blade is rotating 500 revolutions per minute. What is the linear velocity of the tip of the blade in feet per minute? What does this mean, extends out 3 inches from its center?
That's radius.
Okay, so I have a radius equals 3 inches, and I have some kind of a speed as 500 revolutions per minute.
Angular.
It's not linear or angular, because it's not in a distance per time, and it's not in radians per time. What can I make it into?
You can make it into radians.
I can make it into radians per time by multiplying 1 revolution is 2 pi radians. So I get 1,000 pi radians per, whoops, I don't know what happened to my A there, per minute is my angular velocity. It wants feet per minute, so I don't think I want to change the minutes part, right? I want to keep that. What do we do with an R and a angular velocity, which I think is a little omega? I multiply, yes. So I'm going to get 3 inches. Well, I'm going to write that one first. 1,000 pi radians per minute times 3 inches gives me inches per minute, but they want what?
They want feet.
Feet, so 12 inches needs to go in the denominator. So we end up with 3,000 pi feet per 12 minutes. We still need to divide. Comes out nice or not?
Yeah.
250 pi. Now, I don't know about you, but since this is an application problem, I would probably multiply it out. I don't care which way you leave it, but that means it's turning 785.4 feet per minute. I don't know, it seems kind of fast if you stick your hand in the food processor. You might be sorry.
They get chopped up 13 times in 1 second.
So it would hit your finger 13 times if you left it in there for a second? So you get 13 slices? Yes. Number 24, I got all excited and said we have a 5-inch fixed disc. We don't care. We need to know that it is 2 inches from the center, and later they ask us to change that to 1 inch. So for the first part, the radius is 2 inches, and then they ask you to do the question over with a radius of 1 inch. Okay, does that help? The other thing they give us is that it's rotating this fast, which would almost be an angular velocity if we multiplied it by what?
Radians or revolutions?
Yep, so then it will be radians per minute. So we're going to multiply this and this, and you get big numbers both times unless you want to change it to seconds or something. Okay? All right, have a good night, guys. I will be at Cocoa and Cram in the Commons.
At the what now?